Okay, so now we're going to start moving into 3.1. This is all about functions. So the essential question for this section is, what is a function? So we are on page 59. We were just on 48 when we were going through the maintaining mathematical proficiency. And so now from here, we're going to start working our way through this. We're going to start by just working with the definitions. So we have all of these different words that are so important for us to know before we can move forward. One that's not on here, I want to add real quick, and it's something that we talked about in the last section. So let me move this out of the way, is origin. Because this is something that's going to come up quite frequently when we are dealing with graphing functions. So the origin is your starting point. That is the original place of the graph. And all that means it's the point 0, 0. Next, we're going to start looking at the word relation, and we are going to define relation. So if you're ever unsure about definitions or words, you can always refer back to your textbook in Big Ideas. When logging on, there is the option for your ebook. And as you go through your ebook, there's all these different choices where you can start looking at the book and you can click on the words and it'll describe it in detail. And sometimes it may even give you a video. And so we're going to start off with the word relation. A relation is a pairing of inputs with outputs. Next is a function. A function is a relation that pairs each input with exactly one output. And as always, you can pause this to make sure you get it written down completely. Next up is domain. So domain is probably honestly something that you have heard before and that you've dealt with quite frequently. Especially in science classes, you hear it there, but in math, you hear it too. So the domain is the set of all possible input values of a function. So your input values are going to be your x values. So that's what's going to go in for the variable, not what you get as a result. So now on the flip side, looking at the range is the set of all possible output values of a function. And so that's going to be your y values. So that's what you get as a result. Domain is what you put in, range is what you get out. Next up, independent and dependent variables. So again, these are terms that you've probably heard in science classes, and I know you've definitely heard them in math classes before as well. So the independent variable is the variable that represents the input values of a function. So again, this is going to be your x values. So input, independent variable, and domain all are referring to the same part of an equation. Now, as I'm sure you guessed it, dependent variable is going to be the exact opposite. It's going to be dealing with the output output values. So the variable that represents the output values of a function. So again, this is referring to your y values. So dependent, the output, and your range are all referring to the same types of things. So now we're going to go ahead and flip back up to the top of our notes. So we're going to be at the top of page 59, and we're going to start describing a function. So functions can be described in many ways. It can be described by an equation, which we've seen, the y equals 2x plus 4. By an input-output table. So that's when you have your little t-chart and you've got your x values and you have your y values. Using words, so we can describe, okay, it's increasing at a rate of this. A graph, when you can see the exact line, that's a function. We can see that it's creating something. And a set of ordered pairs. So that's, when we're putting things onto a number line, we can create that. So explain why the graph shown represents a function. So when we are dealing with a function, remember, we're only going to have one x value with one y value. So we're not going to have multiple x value or one x value that has multiple y values. There's only one output for every input. Maybe the output is repeated, but it's not because of the input. So the reason why this one is a function is each x coordinate is paired with exactly one y coordinate. So this is something that was in one of our definitions. And so we have one input and one output. So now we're going to describe this in two other ways. So we're going to start simple. We're going to start by just simply giving the x and y coordinates, the ordered pairs for this graph. So we're going to start off at this top one. So the first one is going to be, well, we didn't go left or right any. We don't have an x value, so that means it's 0. And we went all the way up to 8, so that's our y value. Next, we're going to go down to the next one. Well, right away, I can see I went over 1, and I went up to 6. So go ahead, pause here, see if you can figure out the rest on your own without my assistance. So if you're just joining us back, you should have the following coordinates. We should have 2, 4, 3, 2, and 4, 0. And then the next thing that I'm going to do is I'm going to make a t-chart. So I'm going to make a table. And you don't have to work harder on this one. So I'm just going to take the values that I previously had written and write in here. So we have 0 and 8, 1 and 6, 2 and 4, 3 and 2, and lastly 4 and 0. Obviously, there are other ways to do this, but these are the two that I thought was the best for me to do. Alrighty, moving on to 2. This is where we're going to determine if these t-charts or their tables represents a function. And so the biggest thing that we're going to look out for is if we have multiple x values that are the same. We can have the same y values. That is totally okay. But if we have an x value that's repeated with a different output, so a different y value, it doesn't work. So looking at this first one, we have 0 and 8. Okay, 1 and 8. 2, 3, 4. None of our x values are the same. The y's are the same, but that's okay. So we're going to say this one is a function, and it's because one input is paired with exactly one output. Now let's look at the next one. 8, 0, all of our x's are the same and we get different values. So that means if we were to put this on a graph, the line would be going vertically up and down, which is not a function. So this one is not a function. And it's because the value 8 is paired with 5 options. Not possible. Now, on C, it's a little bit different. Now they've kind of changed up how it's written. So now they're saying our input values are 1, 2, 3, and 3. Right away, I see that we have the input value 3 2 times, and we're getting 2 different answers, which is not possible. So this one is not a function. You can't have it repeated multiple times. You can only use the same input value once. Okay, next, this one is kind of fun. I like this one. We get to use the line test. So that's when we're going to draw vertical lines through our graph. If our vertical line goes through more than one point, it eliminates it from being a possible function. So far we're looking good. I've only hit one dot each time until now. I can keep going, but there's no point. Right away, I can see that there's 2 points that are going through that same line. So this one is not a function. So E and F, now we're looking at coordinate pairs. When we're looking at coordinate pairs, the thing that we want to look for is common x values. So I'm not even paying attention to my y values. Right away, I see that none of my x values are repeated, so this is indeed a function. So let's look at the next one. So I'm looking at my x's. Oops, there we go. -2, -1, 0, 1, 2. Well, right away, I see that I have a -1 repeated twice with different outputs. Therefore, this is not a function. So now we're kind of going to get into some interesting situations. It says each radio frequency X in a listening area has exactly one radio station Y. So basically, they're saying when you have a radio station, for example, let's go with Kansas City area. We have 93.3, we have 95.7, 103.3, 105.9. There's no way if you turn to that station, you're going to get a different station than Mix 93.3. The vibe, like that's not going to change. So this is a function. So now we're not going to be thinking about the numbers. We're going to think about the television station. So for example, thinking about like Nickelodeon. Obviously, if you have basic cable, it's only going to appear once. But as soon as you get into like the fancier cables with the HD channels and this and that and other, Nickelodeon's going to be on there multiple times. And so that's the input. It's like, I want to go to Nickelodeon. Well, I have 3 options. So that's why this one is not a function. Now we're looking at just equations. So it says x equals 2. So that means whenever I plug in any single number for x, I'm going to get 2, which right away means that this one is not a function. And then lastly, we have J. It says y equals 2x plus 3. Well, we're not solving it, and x can be any number, and no matter what we plug in, we're going to get a different y value. So this one is a function. The biggest ones I would definitely say to know, and the ones that are going to be the easiest to help determine, is going to be when we're doing the line test, when we're looking at the values, or looking at an input and output table. Those four, or I guess those are really only three types, those are going to be the ones that are so easy to tell if something is a function or not. Okay. And so next, you guys, looking further down, looking at core concepts, so the vertical line test. So that's what we did, and that's what I said was super easy to determine if something is a function or not. We draw that vertical line through it. If it hits our line more than once, it's not a function. If it only hits it once, it is a function. It's the easiest test to do when you have a graph. Just draw that line. If it goes through, only hits once, you are good to go. So domain and range. Domain is of a function is the set of all possible input values. So that is your x. So this is your domain. You put in those numbers, you put it into the function. What you get out is your output. That is also your range. So all of that, all of those things relate together. And it's really important to make sure that we do have those kind of tied together, because that's going to help us further down the line. So next, Mr. Patinsky is going to go through some of those extra practice problems with you guys. So stay tuned, and that's all we have.